Hi friends, today we are going to solve Sherlock and MiniMax problem from the greedy algorithms. This problem is basically one of the most hardest problem. It has the most marks, but in reality I would say it's not that hard, but the way the problem statement has been written is quite arbitrary, or the way the problem statement has been written is not appropriate. It creates a room for a lot of confusion, which could make us wonder how to solve this problem. But if you are able to understand the problem statement, and then you'll be good to go. But the difficult part of this entire thing is the problem statement, which is kind of arbitrary. So let's look at the problem statement. Watson gives Sherlock an array of integer given the endpoints of an integer range. For m in that inclusive range, determine the minimum absolute ARR of I minus m for 1 to I till ARR. Once that has been determined for all the integers in the range, return m. We generate the maximum of these values. If there are multiple m's that result in that value, return the lowest one. So you have been given an example. The array contains 3, 5, 7, 9, and you have an inclusive range of from 6 to 8. So you have taken the values of 6, 7, and 8, and you are going to subtract all the values in that inclusive range with the values present in the array. And once you've subtracted, we'll be taking out the minimum value that's present there. And if you look at the minimum value, then you also are able to find out the result answer. So you choose the lowermost value. Okay, so there are 2 ways of solving this problem. One is the brute force method, but the problem with that brute force method is that it won't pass all the test cases. And there is one more smarter approach. Let's first try to solve this problem with a brute force approach, and once we have, which will be failing basically because it's a hard problem, so brute force method will basically not work. But let's say values, this video is going to be a big one. Min of array, min of values, min values. I'm not going to explain this brute force method because it's just for to show you how this works. This is pretty simple. Anybody with a basic Python knowledge would be able to understand it. I won't be spending much time in this, because if I spend much time in this approach, which is basically going to fail, it won't be worthwhile. So basically in this range, you're taking from P to Q plus 1, is in loop, in Python loops. So basically the loop will start from P and A in that Q. To take the inclusive range of P and Q, so you have to add Q plus 1. And for each in array, we are temp dot append. Here you're subtracting the all the means value of ARR of 1, means whichever value in the inclusive range of P and Q minus each value in that array, and we'll be appending it to our temp value, each minus 1. And once that temp value is completed, or our each loop has been done, we'll be appending that temp value to our values list. This is the concept. Anyway, if you're just not interested in the brute force method, you could always go forward this video and check out the proper approach of this one. Now here we will be checking, basically counting the minimum values that are present there, which values are minimum. So as you could see in this entire context, the value of 1 was the minimum. So that's the That's why I've taken the minimum value. And here also we will count how many minimum values are present. So if you look at this case, in 6 case, there are 2 ones present there. So that's the idea. So here we'll be appending the minimum value. Along with that, we'll be also appending the count of that minimum value present there. Min of each, then each dot count min of each, and here we'll be creating some variables. Max equal to -1, id equal to -1, count equal to 0 for I in range of 0 to length of min values. Here we'll be checking which values is the minimum and which has the maximum number of those instances present. So if min values of I comma, it's a nested list, so I dot 0 is greater than max, or min values of I, sorry, min values dot count min values of I comma 1 is greater than count. Max would be min values of, I guess, I comma 0. The syntax is pretty basic, but it could be a bit of confusing. So if anybody is trying to understand this, please read the code. Also, I will link the GitHub where I stored in the entire code. You could always go there and check it out. And once you have done that, we'll be returning, because here the issue is that we have not taken the in which range value we have not taken it. So our basic understanding would be if the loop is looping from 0 to up to an n, and here the inclusive range starts from, for example, it's from n to m. Then to get our exact range, you could basically say n plus the current values of I. So this is the basic idea. Although it's kind of superficial as of now, but if you look at the code, I hope you'll be able to understand it. Let's run the code. I hope it should run past the public test cases. Okay. As you could see, it passed the public test cases. Let's submit the code and see. Made some mistake perhaps, because in my case it generally passes the test cases. Let's check. Agent values min of each dot count min of each, max -1, id count 0 for I in range 0 to length of min values. If min values I would say, or min values dot count min values I1 greater than count min values equal to Pretty strange. Let's check again in case you're able to find it. Anything? I got the error. It should be each minus I. So basically, we have to subtract the value. That was the mistake I was making. Let's submit the code again. Basically, I guess 3 values won't pass because of the brute force error. I guess it would give us runtime error. Okay, so this is the basic code here. Right now, we have to solve this entire thing in a much more simpler approach. So I've written an algorithm to solve this. I guess if you go through this, probably you would have a better understanding. So if you look at this code, if you look at this algorithm, so first you have to sort the entire array and then you have to find the mid. Where to find the mid is that, for example, let's take the array of 5, 7, 9 and 13. The mid values is been created by 5 plus 7 divided by 2, 6, 8 and 11 in order to get the mid values, and you'll be get the optimal m. So basically you'll be checking if the mid value 6 minus 7 is, what's the value of 7. We'll be finding the value is 1, which is obviously greater than the initial mid value of 0. So thus our answer becomes 6. Similarly, we'll be checking it from 8 minus 9. The minimum value is 1, so no need to change. It's not greater than the current mid value. And then from 9 to 13, once you'll be checking it, we'll be finding out that the minimum value after subtracting 11 from 13, the minimum value is 2. So our current answer would become the mid value. Similarly, there are some boundary conditions need to be checked. If the leftmost of that P and Q is less than the smallest value in the array, then our current aim would become P, and we have to check if the current min value is 5 minus 1, which is 4, and you have to check the answer. Similarly, you have to go and check for the right hand value. If the right hand value is larger than the current value in the array, in the same way you have to do this. This is the basic idea. Now let's go to the code. So if you look at the algorithm, the first step was sorting the array. Sorted array. Then we'll be creating some variables called new array. it would be a list and initializing an empty list, and there will be creating minx, which value would be initializing with -1, and the answer that we need to return again initialize it with -1. Now let's go for the looping. For I in range of 0 to length of array -1, in order to calculate the mid value is basically array of I plus array of I plus 1 double divide by 2. The reason for using double division so that you don't get a floating point value. So double division ensures that we get an integer value. So we have to check if the mid value is less than equal to q, and the same time mid value should be greater than equal to p, and mid minus array of I should be greater than minx. Then we could initialize our minx with mid minus array of I, and our answer would be the current value of the mid. Else or elif, we're checking the boundary conditions now. If the mid value is greater than q, if q minus array of I is greater than minx, q minus array of I, and the answer would become q. If mid value is less than p, almost same kind of operation, array of I plus 1 minus p if it's greater than minx. Slight spelling error. And one more thing, our indentation is wrong. Need to check the indentation. Written the same code twice. And last we'll be returning our answer. Whatever code I've written is strictly following the algorithm that I just written in the pen and paper. Let's check if it's correct. It's wrong. I guess few cases are not passing. Let's see if I've made some mistake like the previous one that I did. You could also check the boundary condition beforehand also. Let's see if it works. P greater than array of 0 if array of 0 minus P greater than min-x, then our current min-x value would become array of 0 minus P, and our current answer would become. Similarly, for the Q part, if Q is greater than array of, oh, I forgot, in the code that I've shown you, if you look at the third step, so you have to first check if the current value of P is smaller than the smallest element in the array, and similarly you have to check if the Q value is greater than the largest value of that value in the largest value of element in the array, then we have to check these conditions, and I didn't. So again, let's do it. Array of 0 greater than min-x equal to Q minus array of -1, and answer would become Q. Let's see if it works or not. I hope it does, as always. Let's submit the code. Finally. So finally the code is compiled and almost successfully. I know this code is a bit complicated. There are too many things to make sure it works correctly. But if you as I always keep on saying you, if you have a better way of solve this similar problem in a much better approach, then please comment below so that I could refer to that and also could improve my own horizons of knowledge, as well as anybody who is referring to this video could get an idea of how to solve this entire problem in much more easier way. I don't think this is the most best method of solving this problem. There should be some easier way of solving this. And honestly, I tried a lot. I tried for a few days. I was trying to find a better solution and I didn't. So this is the most optimized code that I have been able to write. But it does not mean that if I have failed to write an optimized code that you would face a similar situation. So if you have a better way of solving the same problem, do comment below, do share your knowledge with me and with everyone in the internet so that they could also improve their coding skills. And as always, I keep on saying thanks for watching the video and stay tuned.